Okay, so let's move on further.
Now, next we refer to some planet configurations. Configurations basically means a particular location of the planet in its orbit. So the terms which are used to represent or show planet configurations are conjunction, number two, opposition, and number three, quadrature. They basically tell us about the position of a planet with respect to the sun. Let us now understand all these three configurations or all these three terms with the help of a diagram. Let's show the sun in our diagram. Then around the sun, we show planet Earth. I have shown it in blue color. Our Earth is a blue planet. And let's show the orbit of the Earth now. We have the orbit of the Earth on the diagram. Now let's show another planet of the solar system. We show the red planet, and it is the Mars planet. We are aware that the orbit of Mars is greater than the orbit of the Earth. So let's now show the orbit of the Mars. We have the orbit of the Mars in our diagram. Now both Earth and Mars are revolving around the sun in their orbits. The speed at which they are revolving around the sun is different. They are revolving around the sun with different speeds. All the planets have different speeds. We just saw the third law of Kepler's planetary motion, which said t square by r cube is equal to constant. So as the radius keeps on increasing, the time period also keeps on increasing. So that tells us that the angular speed with which the planets revolve around the sun will also keep on changing from planet to planet. Now, with varying speed, it is possible that the Earth and a particular planet may be at different locations with respect to the sun. Like, for example, right now when you see in the diagram, you can see that for an observer on the Earth, the sun as well as the planet Mars are in the same direction. Both the sun and planet Mars are in the same direction. Now, this particular placement of the planet with respect to the sun is called as conjunction. We say that this particular planet or planet Mars is in conjunction with the sun. So this is the meaning of the first term, which is conjunction. Basically means that the planet is in the same direction as the sun. The planet is in conjunction with the sun. Now let's say after some time, we keep on observing this particular planet, and this particular planet moves to a different placement in its orbit. And right now, the planet has moved to this particular placement, this particular location in its orbit. Now, for an observer on the Earth, with the planet Mars at this particular location, you can see now that the sun and the planet Mars are opposite to each other, or they are in opposite directions. The sun is in one particular direction and the planet Mars is exactly in the opposite direction. Now this particular orientation is called as opposition. We say the planet Mars is in opposition to the sun. So opposition basically means that that particular planet and the sun are in totally opposite directions. Now, let's assume that the planet keeps on moving in its orbit with some relative speed. And at another particular instant, we observe that the planet Mars is at this particular placement or location in its orbit. Now, if you observe this planet Mars carefully, you see the direction in which the planet Mars is at right angles to the direction in which the Sun is. So whenever a planet is at right angles to the direction in which the Sun is, it is called as quadrature. So this is the planet Mars in quadrature. The direction in which the planet Mars is 90 degrees away from the direction in which the Sun is. Now there is a possibility, another possibility of quadrature. If the planet Mars at a particular instant reaches to this location in the diagram, you can follow the laser pointer. So at this particular location also, the direction in which the planet is at right angles to the direction of the Sun. So it tells us that this particular planet is in quadrature with the Sun. So conjunction means the Sun and a particular planet are in the same direction or the angle between them is 0. Opposition means that the direction in which the Sun and a particular planet are exactly opposite to each other, or the angle between the Sun and that particular planet is 180. And quadrature means that the direction in which the Sun is 90 degrees away from the direction in which the planet is, or the angle between the Sun and the planet is 90 degrees. Now these terms are important from the point of view that whenever we get numerical based on Kepler's laws of planetary motion, sometimes these concepts are used in the question. So we should be aware of what these terms means to accurately solve that particular question. So this is the importance of understanding these terms.
सर
हाँ बोलो बेटा।
सर ये जो यहाँ पर मतलब जो क्वाड्रेचर बन रहा है ना, ये अर्थ के ऊपर अपन ने खींचा है परपेंडिकुलर। अगर ये सन के ऊपर अगर अपन खींचे सर तो भी तो मतलब बनेगा ना क्वाड्रेचर?
नहीं बेटा, ये सारे के सारे जो टर्म्स हैं या प्लेसमेंट्स हैं, दे आर फॉर ए ऑब्जर्वर ऑन द अर्थ। तो अब हम सन पे तो जा नहीं सकते, सन पे जाएंगे तो राइट, तो साइड लेने की जरूरत ही नहीं है। वी विल बी अ साइड आवरसेल्व्स। तो दैट्स व्हाई ऑल दीज आर विद रिस्पेक्ट टू ए ऑब्जर्वर ऑन द अर्थ सरफेस।
ओके ओके।
सन और प्लेनेट के बीच में एंगल 90 डिग्री
पर सर जो
होगा।
कंजंक्शन अपोजिशन है दैट इज द मास, सर।
Yes, Mars is in conjunction with the Sun, Mars is in opposition with the Sun, and Mars is in quadrature with the Sun. This is how we say it. Okay, beta? All right?
Yes, sir.
Okay, so these were the three important terms.
Now the next important concept which we have is the concept of elongation. Let's understand what elongation is. Elongation of a planet is the angle at the center of the Earth between the Sun and that particular planet. Let's try to understand it with the help of a diagram. We have the Sun in our screen now. Let's show the planet Earth. We can also mark off the orbit of planet Earth. You can see the orbit of Earth in blue color. Now let's show another planet. In this case, we show planet Venus. Now Venus is closer to the Sun as compared to the Earth. So let's now mark off the radius of the orbit of Venus also. You can see the orbit of Venus in maroon color as shown by the laser pointer. Let's now try to show the radius vector of Venus as well as Earth. So you can see this dotted line joining the center of Sun with the center of the Venus. This marks off the radius vector of planet Venus. Similarly, you can see this blue color dotted line showing the radius of the Earth. Now let's draw another line joining the center of the Earth and the center of the planet Venus. So you can see this red color line joining the center of Earth with the center of Venus. Now from this diagram we can easily understand what elongation is. You see this red highlighted angle in the diagram is what is elongation. Let's try to match with the definition of elongation. The definition says elongation of a planet is the angle at the center of the Earth. You see this red angle is being made at the center of the Earth between the Sun and the planet. So from the center of the Earth, a line joining the center of the Sun and a line joining the center of the Venus, angle between those two lines is the elongation. So angle at the center of the Earth contained between the Sun and that particular planet is known as the elongation of that particular planet. Now, as Earth and Venus are moving with different orbital speeds, different angular velocities in their orbits, their location with respect to each other will keep on changing. The planet Venus could be at any particular elongation depending upon what is its position in its orbit. Let's assume that if planet Venus is at this particular position here, the elongation will be the blue color line showing the radius of the Earth and the line joining the center of the Earth with the location of Venus at this particular point. If Venus is at this particular location here, the elongation will again be by the angle between the radius of the Earth and the line joining the center of Earth with center of the Venus. Now, if you look carefully, that as the planet Venus moves in its orbit, you can follow the laser pointer. At this particular point, Venus will be in conjunction with the Sun, or the elongation will be 0 degrees. Now, as it moves in its orbit, the elongation will start to increase. At this particular point, at the first location, it will have a certain elongation. After this, the elongation will keep on increasing. Now, if you look carefully at this particular point, Venus will have the maximum elongation. The angle at the center of Earth will be maximum at this particular placement of Venus in its orbit. As Venus moves forward in its orbit, you see the elongation will start to reduce again. Now, this point where the maximum elongation occurs, if you look carefully, you will see it is the point where from the center of Earth, if you draw a tangent to the orbit of Venus, the tangent meets the orbit of Venus at this particular point. This is the point where Venus is going to have maximum elongation. And we are aware that the tangent is always perpendicular to the radius of a circle. So this line joining the center of Earth with the center of the Venus, the red dotted line, represents a tangent, and this line joining the center of Sun with the center of Venus represents the radius of the Venus. So they will be at right angles. So this angle here at planet Venus will be 90 degrees. So this is the point of maximum elongation of Venus, and we know at the point of maximum elongation, the angle made at point Venus between the Sun and the Earth would be 90 degrees. Now, this particular diagram is used in solving some of the questions. So you should be clear about the concept of maximum elongation and what is this angle which is made at the planet at the time of maximum elongation. Now, if you consider a exterior planet means the planet whose radius is greater than the radius of the Earth, like say for example Mars. Now, the maximum elongation of Mars is going to be 180 degrees. The maximum value of elongation is possible, which it can be, is 180 degrees. For a exterior planet like Mars, it can reach up to its maximum elongation, that is 180 degrees, when it is in opposition to the Sun. But for a inferior planet like Mercury or Venus, the maximum elongation will be less than 90 degrees, and it will depend upon the radius of that particular planet and the radius of the Earth. Now, inferior planets like Venus, as you see in this diagram, can never be in opposition to the Sun. They can never be in opposition. Irrespective of whichever position they are in their orbit, they can never go in a direction which is opposite to the direction of the Sun. And at the same time, if you look carefully, you will observe that these inferior planets like Mercury and Venus can also never be in quadrature with the Sun. To be in quadrature, the angle at the center of the Earth or the elongation has to be 90 degrees, which is not possible in this particular case. So opposition and quadrature can only be attained by exterior planets whose radius is greater than the radius of the Earth. And for inferior planets like Mercury and Venus, whose radius is less than the radius of the Earth, they can never be in quadrature and in opposition.
यार बट इसके दो कंजक्शन हो गए ना, दो कंजक्शन इनफेरियर प्लैनेट्स के.
Yes, beta, that's right. They will have two conjunctions. One conjunction will be when the planet is in between the Sun and the Earth. Other conjunction will be when Sun is in between the planet and the Earth.
Now we have learned some concepts related to the motion of the planets in the solar system. Let's now try to see what type of questions are formed on the basis of these concepts. We have the first question now on the screen. Jupiter has an orbit of 11.86 years. This 11.86 years is the orbital time period of Jupiter. Calculate the distance between Earth and Jupiter when Jupiter is in opposition with the Sun. So they told us that Jupiter has a orbital time period of 11.86 years. And they have also told us that Jupiter is in opposition with the Sun, means looking from Earth, Sun and Jupiter are in opposite directions. And we need to find what is the distance between the Earth and Jupiter. Let's try to understand this question using a diagram. Let's make the Earth in our diagram here. We show the orbit of the Earth also. We have the Sun also in our diagram now. And we now know that Jupiter is in opposition with the Sun, means Jupiter is in opposite direction to the direction of the Sun. So Jupiter has to be here. You see, in this particular place, for an observer on the Earth's surface, the Sun and Jupiter are in opposite directions. Now we can show the orbit of the Jupiter also in our diagram. And we now need to find out this particular distance. That is the distance between the Earth and the Jupiter. Now, how can we obtain this distance? This is what is required. Now, if you look carefully, if we join the center of Earth with the center of the Sun, this is the radius of the Earth. It is represented by the blue color line in the diagram. This is the radius of the Earth. And if we measure the distance between the center of the Jupiter to the center of the Sun, which is represented by the red color line in the diagram, which I am highlighting with the laser pointer, is the radius of Jupiter. Now you can clearly see the distance which is required by us is equal to radius of Jupiter minus the radius of Earth. So orbital radius of Earth is known to us. It is 93 million miles. The orbital radius of Jupiter is not known. So is there a way we can find out the orbital radius of the Jupiter? Yes, certainly. We can find that in this question using the Kepler's third law of planetary motion, which says t square by r cube is equal to constant. So you place the t square by r cube of Earth equal to the t square by r cube of planet Jupiter. We have the orbital time period of the Jupiter as 11.86 years. So the only unknown in the equation will be the orbital radius of the Jupiter. So once you get the orbital radius from the relationship, you can subtract radius of Jupiter minus radius of Earth. It will give you the required distance, which is the distance between the Earth and Jupiter.
So will you be able to do this better?
Yes, sir.
You're right.
So ये जो जुपिटर का टाइम 11.86 ईयर्स दिया है,
Right.
सर उसको कन्वर्ट करेंगे सिर्फ 365 से करेंगे ना सर? 365.25 तो नहीं लेंगे?
नहीं बेटा, no need of converting it to days. You can keep it as years only, na? For Earth it will become 1 year, and for Jupiter it will be 11.86 years.
Okay sir, okay sir.
That will be much simpler. The
Yes, sir.
calculation would be much easier. Now, since this is a comparison, we are comparing t square by r cube of Jupiter with t square by r cube of Earth. You can use any units of your choice. Only thing is that whichever units you use for one planet, the same units should be used for the other one. That's all. Otherwise, you can use any units.
Yes sir.
Okay. Let's continue.
Let's see one more question based on these concepts. The question says, if the sidereal period of Venus is 224.7 days, sidereal period means the orbital period. Venus takes 224.7 days to complete one orbit around the Sun. So if the sidereal period of Venus is 224.7 days, find its maximum elongation. So let's try to make a diagram to understand how do we proceed in the question. Now we know that elongation is the angle at the center of the Earth contained between the Sun and that particular planet. So let's make a diagram. Let's first show the Sun in our diagram. We can show the Earth next. And we also show the orbit of the Earth in blue. Now let's show the orbit of Venus. We have the Venus planet here. and you can see the orbit of Venus also in the diagram. Now let's join the center of Sun with the center of the Venus. This basically is the radius vector of Venus. And let's now join the center of the Earth with the center of the Sun. This is basically the radius of the Earth. Let's now join the center of Earth and planet Venus also. So you can see this is the particular case or particular condition in which this line joining center of Earth and center of Venus is tangential to the Venus orbit, telling us that Venus is going to attain its maximum elongation at this particular point. And the elongation here is this particular angle, the red color angle which you see, the angle at the center of the Earth between the Sun and the planet Venus. This is what we require. So this is the elongation, maximum elongation of Venus. Now, we are aware that at this point of maximum elongation, the angle at Venus between the Sun and the direction of the Earth has to be 90 degrees, because this line joining the center of Earth with the center of Venus is a tangent to the orbit of Venus, and the line joining Sun and Venus is the radius of this orbit. So tangent and radius are always at right angles, so that's why you see this angle is 90 degrees. Now if you look carefully in this particular diagram, it is a right angle triangle, and we need to find out the red angle, the elongation. And in this particular diagram, the radius of the Earth is known to us, orbital radius of the Earth, which is 93 million miles, 93 into 10 raised to power 6 miles. And if we also know the radius of Venus, then we can very easily calculate the elongation. How can we calculate it? We know sine theta is equal to perpendicular upon hypotenuse. So if we take sine of elongation, it will be equal to radius of Venus divided by radius of Earth. You see, in this particular triangle, radius of Earth is the hypotenuse. It is the side opposite to the right angle. And the radius of Venus is the perpendicular considering this angle, the red angle. It is opposite to the angle, so it is the perpendicular. So if we have the radius of Venus and the radius of Earth, we can easily find out the elongation using the sine theta relationship. Now radius of Earth is known to us, radius of Venus is not known, but we can easily calculate the radius of Venus using Kepler's third law of planetary motion, which tells us that t square by r cube is constant. We know the t square and r cube of the Earth, and we also have the sidereal period or the orbital period of Venus as 224.7 days. So when we put this value in the t square by r cube relationship, we can easily find the orbital radius of Venus, and using its orbital radius, the elongation can be easily calculated. So this is how we solve this elongation question. The answer to this question is 46 degrees, 19.8 minutes.
So this is also understood, beta. Will you be able to do this?
Yes, sir.
Okay. All right.